Welcome back, guys. Today we'll be doing January 2020 CSEC Mathematics question 6 in the triangle. For this question, the radius of each circle in the rectangle WXYZ shown below is 7 centimeters. The circles fit exactly into the rectangle. So this is the rectangle W, X, Y, and Z. And these circles, as they stated, it fits exactly in the rectangle. Now, it asks us to show that the area of the rectangle is 2,352 centimeters square. Now, we need to find the length of WX. If you look closely, I have the radius, which is 7 centimeters. So it means from the center to this point is another 7 centimeters. And then from the circumference to the next center is another 7 centimeters. And then from the center to the circumference again, that's another 7 centimeters. And then from the circumference to the center, that's another 7 centimeters. Hopefully you're seeing the trend. From the center to the circumference, that's another 7 centimeters. And we have from the circumference to the center is another 7. And finally from the center to the circumference, that's 7. So if you're seeing 2 of the radius becomes a diameter. So the diameter assisting us with finding out the length of WX. Realize how many radius we have from the center to the circumference. This is 1, this is 2, this is 3, 4, 5, 6, 7, 8. So it means to find out the length of WX. So just to find out the length of WX, I'll multiply 7 centimeters by 8, and that will give me 56 centimeters. So all that is happening is that I want to know the length of WX. In order to find out the length of WX, we have to look at the information that we have. From the center to the end of the circle, I have this to be 7 centimeters. So it means right here is also 7 centimeters. In other words, the diameter for one circle is 14 centimeters. So this is 14, this is another 14, another 14, and another 14. So adding this up, you will also get 56. So this gives me the 4 circles, the diameter or the radius in it gives me length of WX. Now I also need to find out the length of WZ. So let's erase this. So I want to find out the length of WZ. So we have 3 circles and we know the length of one of the radius. The radius is 7 centimeters. So if the radius is 7 centimeters, it means that from here to here is 7, then I'll have another 7. Then from this circumference to this center is another 7. And then from this center to the next circumference, that's 7. And then from this circumference to this center is another 7. And it continues. In other words, the diameter for each circle is 14. So if we don't want to use 7, we can use the diameter, which is 14 times 3. And that will give me 42 centimeters. Just remember that this will also be 7 centimeters. So the two radius, this is radius 1, radius 2, the total gives me the diameter, the length of the diameter. So it will be the same scenario here. This radius will be 7 centimeters. And the next end from the center to the circumference is another 7 centimeters. Same case here, this is 7 centimeters. Along it from the center to the next circumference, that's 7. So we can either say, okay, we have 1, 2, 3, 4, 5, 6. So we will 6 times 7, that will give me 42. Or we look at the diameter, where we have 1, 2, 3 diameter, and each diameter measures 14 centimeters. Now we need this information in order to find out the area of a rectangle. The area of a rectangle is equal to length times width. So therefore it will be 56 centimeter multiplied by 42 centimeter, and calculating this, I will get 2,352 centimeters square. Now the second part asks to calculate the area of the shaded region. We have the area of the rectangle. The shaded region is a region where it's not covered by the circles. So I can find the area of one circle. Then if I know what is the area of one circle, I can find out what's the area of all the circles. Finding the total area for all the circles, I can subtract that area from the area of the rectangle, and that will give me the area of the shaded region. So we want the area of the shaded region. So the area of the rectangle is 2,352 centimeters square. That's what we know. So the area of the shaded region is equal to the area of the rectangle minus the area of the circles. So if I'm able to find out the area of each circle and find the total area for the circles, once I subtract it from the area of the rectangle, I'll be able to get the area of the shaded region, which is the region in which the circles are not overlapping. Now, we already know the area of the rectangle. The only thing I don't know is the area of the circles, but we can find it. Now, the area of a circle, and I'll have it in pink. Pink represents the area of the circle. We know it's pi r squared. So pi, I'm going to use 22 over 7, and r is the radius. Radius is 7, so I'll have 7 squared. Working this out, the area of my one circle is 154 centimeters square. But we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 circles. So to find out the area of the 12 circles, which is the total area of the circles, is multiplying this by 12. So multiplying 154 times 12, I will get 1,848 centimeters square. So this represents the total area for the circles that's within this rectangle. So to find the area of the shaded region, I will have the area of the rectangle, which is 2,352 centimeters square, minus 1,848 centimeters square. Now subtracting this, my answer will be 504 centimeter square. So once again, we found the area of the circles. We can find the area of one circle, then multiply it by 12 to find the area of the total circle that is within this rectangle. After finding the total area for the circles within, we can subtract it from the area of the rectangle, which was found on the previous slide. So subtracting, this represents the area of the shaded region. Now the next question that we have here, the diagram below, not drawn to scale, shows the triangle MNP in which the angle MPN and the angle PMN equal 52 degrees. MN is 12.5 centimeters. Now the question is, what type of triangle is shown here? This is known as an isosceles triangle. An isosceles triangle has two angles that are the same, and it means that the two sides are also the same. So this is considered to be an isosceles. An isosceles triangle has two angles being the same and also two sides. So if this is 12.5, then it also means that the next side, which is PN, is also 12.5 centimeters. Now, determine the value of angle PNM. This is the angle that we need to find. We know that in a triangle, the angles add up to give us 180, and we already have two angles. So we'll say 180 minus 52 plus 52. So calculating this, 52 plus 52 is 104. So I have 180 minus 104. That will give us 76 degrees. So the angle that's missing is 76 degrees. Next, we want to find the area of the triangle MNP. Now, since it's not a right angle triangle, we can use this formula. The area is equal to half AB sine C. Now, remember, the angle C is between the two sides A and B. So since we're not using A and B, but we have P, M, and N, let's manipulate this formula. So this is angle P, so the side that is facing it is called side P, so I'll call this common P. This is angle M, the side facing it is called common M, and this is side facing it will be common N. Remember, I found out that this is 76. In order to use this rule, we have to have the angle between two sides. So we can't use the 52 because we're not aware of this side. However, you could find it using cosine rule, but we don't need so much steps in finding that information. We already have enough information here. I have 76 and I have 12.5. So manipulating this formula, A is equal to half. Instead of A and B, I'm going to have P times M sine capital N. Now we know what is capital N. So we have a half. Side P is 12.5. And the next side is also 12.5. So we will have 12.5 times m is 12.5 also times sine 76. Now all of this could enter into your calculator. A half times 12.5 times 12.5 times sine 76. And when you enter this into your calculator, you're going to get 75.8, and the unit is centimeters square. And that's it. Thanks for watching, guys. Don't forget to like and subscribe to my channel. Have a great day.